right, so the third function is 3 sine theta over 2. All right, what is your amplitude? What is it?
Which one? The amplitude?
Uh-huh.
A plus minus A. Or no, it would be 3 plus minus 2.
Yes, right?
Yeah.
Okay, it's going to be, the A value is 3 because this is A, right? So that means my amplitude, so if we kind of do a messy sketch, we're doing the sine function, right? So the sine function starts at 0, and this would be 1 cycle, right? Okay, so that means the max is at positive 3, and my min is at negative 3, right? That's my max. That's my min. I was going to write max again. I don't know why. Okay, yeah? So far? Okay, that's the easy part. So now the period becomes, it's 2 pi over b. Okay, what's the value of b here?
2.
But where's the 2? Huh? Yeah, so I know you see this, so it's technically, right, a sine b theta. You're given this, but it's really 3 sine 1 half. Why is that a Q? It looks like a Q. Theta. Yeah, so you guys understand, theta over 2 is really 1 half times theta, right? So then what's my b value? What'd you say? More.
1.
What's the b value? 1 half.
Oh.
Yeah? So my b value, right? So this is A. This is B. I know B is right here, but I don't want to mark it, right? Because you guys understand that 1 half theta is the same as theta over 2, right? So my b value is 1 half. Okay, so the formula is, if you want to recalculate the period, it's 2 pi over my b value, and then you have to clean it up. The first one we didn't have to clean up. The second one you're going to reduce a little bit, the second function. The third function, we'll do it by hand, and we'll also type it in the calculator. So this becomes 2 pi, but we agree my b value is 1 half. So it's 1 half. Whoops, you can't see. Okay, so then let me cover this since we don't need to look at it anymore. So I'll just take it away. Right? Okay, now, you guys, calculators? Yeah, you guys need calculators. Okay, no lie, like, it was only 3 of us. It was Ezekiel, Ariana, and me, like, at 8:27, and we're like, is anybody showing? You guys are like, I don't know, are you guys tired today? You feeling the Wednesday, what?
Traffic.
Oh, there was traffic?
Yeah.
Why? Wait, like, really?
Yeah.
I wonder why, what's today? March 14th, 13th? Oh, people know how to drive. No, we were like, where is everybody? We're alone. Oh, yeah. Oh, yeah. Oh, yeah, it's all red. People don't know how to drive. Okay, you guys good? All right, so remember, when we get to the part, I'll tell you guys, you're now im3. You should always check the calculator. Is it in D mode? Is it in R mode? Okay, but we're going to eventually cut into quarters. So at first, I'm going to work with the degrees, and then I'll work with the radians. So if you want to keep the calculator in degree mode, we're going to first convert, and then afterwards, I'll put it in radian mode, and we'll type it, in the calculator. So we're going to do both today. That's what I'm going to talk a lot. Yeah.
Wait, where'd you get the 2 from? Like the 1 half? Like where'd you get the 1 half from?
The b value. Theta over 2, which is equivalent to 1/2 theta.
That's always 1/2. Theta over V is always.
No. So like, okay, what's your, okay, remember it's, wait, I don't know what you guys can see. Okay, AB, right? So what's your B value here?
3.
3. What's your B value here? 2. What's your B value here?
Oh, theta over 2.
But we don't count the theta.
Just 1 over X.
Right.
Or 1 over 2.
Yeah.
And then where'd you get, oh, so that's where you got the 2 from. Well, can you show me how you got 2 for B on the second problem?
Here?
Yeah.
Yeah. What you just said.
Oh, okay. Thank you.
And remember, the numerator is the calculation to find the period. So 2 pi, because that's your standard revolution.
It's always 2 pi?
It's always 2 pi because that's your unit circle is 360, which is equivalent to 2 pi. Okay. Okay. Okay, calculator then. So we just want regular calculator. What am I in? I'm in radians. Hold on. Let me go to degrees. Not that it matters. Okay. So what happens is now if I have fraction 2 pi, wait, can you see? Yeah. And then I'm going to hit fraction because my denominator's the fraction. You're not going to go fraction. You have to know which one is your fraction. You're like, what is she saying? Okay, this is what I'm saying. Here, let me, I just spoke some nonsense right now. Okay, look. It's not, look, when you have 2 pi over 1/2, it's really, your numerator is 2 pi over 1, your denominator is 1/2. Your fraction is in the denominator's position. It's not, oh, by the way, you're going to end up getting 4 pi. Okay. But hold on before that. Okay, if you guys went fraction, you're making your numerator the fraction. So if you go 2 pi 1, 2, what you have here is not this. You have 2 pi over 1 over 2, which is 2 over 1. You reciprocaled your denominator. You gotta know.
Oh, you flipped it.
So you have to understand that, and then this one gives you pi. So yeah, it matters what you're typing into the calculator, because one of them is a fourth shorter than what our period should be. Our period should be 4 pi, but this is pi. So, like I said, you gotta know, you gotta push the buttons yourself. Okay, you can't have your friend do it, you gotta push them yourself. So, you have to understand, my denominator is the fraction. So, it's fraction 2 pi. Now you're in the denominator's position. Now I'm going to hit the fraction again. 1/2. 4 pi. Yeah? Okay, by hand. If you're like, well, what's all this calculator stuff? Why don't you just teach me by hand? Okay, what's the reciprocal of 1/2?
2 over 1.
2 over 1. Okay, but what you do on top, on the bottom, you have to do it to the top, right? Top and bottom has to be equitable, because then this is just 1 on the bottom, right? Okay, so then what's the top? 2 pi is really over 1, and so what's 2 pi times 2? 4 pi, and there's your 1, and so there's your 4 pi. By hand always works. That's why your teachers wanted you to learn to solve everything by hand, because when you guys get into your higher math with your calculators, you know, garbage in, garbage out, if you guys are doing your double click, well, you started off with garbage, so your answer is going to be garbage. That's computer programming, you're coding. It's very frustrating. Okay, all right, so, okay, so there's my 4 pi. Okay, so now, what I have here, oh, I didn't need to draw it, but we kind of will. Oh, that's okay, actually. It'll just be a really long line. Okay, so that means I'm starting at 0 and I'm ending, what's that gonna be? What's my end? No, it's my start. Oh, you're giving me the value. No. In terms of the x-axis being in radians, what's that gonna be? If this is one cycle, and you know your period, what's this gonna be? More. 4 pi, right? Because you recalculated your period, right? So you calculate the period and you clean it up because this is the end. So that means that one cycle is now altering to 4 pi. It's elongating, right? It's getting stretched. It's getting horizontally stretched out to 4 pi. Okay, so this will be easy. All right, so we're still going to convert it to degrees just in case you need it. But you should be able, you guys aren't going to need any calculators, you'll know this. All right, look. Your unit circle is 4 quadrants. Quadrant 1, 2, 3, 4. So when you get your period and it's 0 to 4 pi, you have to break it up into 4 quadrants, 4 sections. All right, you're going to easily know what are each of these ticks going to be. What's this one here? 2 pi. And then what's this one? And then what's this one? 3 pi. Yeah, so this one is like, this one was really, really nice. It's just this was the ugly part of, do you know how to use a calculator? Okay. Okay, so now you have your graph. You have your, you now know this is, what am I doing? This is 1 pi, this is 2 pi, this is 3 pi, and there's your 4 pi, and now you can graph them. Okay, now, if you wanted to convert, let me just do it, even though you guys understand your 1, 2, 3, 4. If we go to convert, if you're not very good with this, take your 4 pi, times it, times it, and convert it to degrees, and I get 720 degrees. Okay, so from 0 degrees to 720 degrees, you guys are very, very good at cutting everything into 4s. And so if this is 720, you guys know, okay, let me divide 720 by 2, and I get 360, so I know this is 360. And you guys should already know 360 is equivalent to 2 pi. What's half of 360? 180. And you guys already know pi is 180. And then this is, yeah, 540. Good job, Brandon. Okay, so 180, 360, 540, 720, and you could check every one of these sections is 180. And so you could even grab a calculator and check. Okay, so what's 180 plus 180? 360. What's 360 plus 180? 540 plus 180, 720. And so there are 4 equal parts. Okay, and then if say, right, because this one was an easy one, but say for instance now you want to convert it back, then that's fine. You take 180 times pi 180, and there's your pi, so 180 is back to pi. So if you have issues cutting up your period, because you need them in quadrants, then, because that's your, you start at 0, the sine function starts at 0. Within the first quadrant, the first fourth section, it's going to hit the max. Then if in the second section, it falls back down to 0. The third section, it gets to your minimum, and then it works its way back to the restart to 0. Okay, so you got to be able to hit your 4 parts. All right, so you guys can now graph this one. Now, for your graph, if you guys want to put some effort into, right, because you guys already know it's going this. If you now want to put some quarters in there, You can, if that's pi, this is what? Pi over?
4. No. Over 2.
Right.
Yeah.
Pi over 4 would be here.
Yeah.
So you could do pi over 2. Now, if you're like, oh, I kind of don't get that. Well, what's half of pi? Pi over 2. So this is 1 pi over 2. This is 2 pi over 2. 3 pi over 2. 4 pi over 2. 5 pi over 2. 6 pi over 2. 7 pi over 2. 8 pi over 2. And so now, if you want to throw it into the calculator, and so now let me go to radians, 4 radians. Okay, so now if my function is 3 sine theta, and say I want to put pi over 4, you know what? I'm going to do the 1/2 first. 1/2. I'm going to section it off. Because then I don't want to deal with fraction. Okay, so times, and then I want to put in, what am I putting in? Pi over 4. I get 1.14, and so this is going to be, if this is at 2, 1.14 is like right there. And then if I want to put in pi over 2, 2.12. Did I type the wrong one in? 2. Oh, I went to 2. It's supposed to be 3. Sorry, you guys. I thought my max and min were 2 and -2. Okay, so 1.14. So then pi over 2 is 2.12. So 1, 2, 3. Oh, it's a little off. Okay, 2.12. If I throw in pi, can you guys still see? Yeah. Okay, so if I throw in pi, I don't want to take out the fraction. I'm just going to put 1. Okay, then I get 3, and there's my max, right? So that's what I'm saying at pi. And you guys can just start plugging them in, and you're going to get all those little points. Okay, it is within your best interest to start cutting it. The more you cut and the more you get more points to represent your function, your brain is registering how to cut your radians, okay? Because they're in fractions. You're not going to give me graphs in degrees. They have to be in radians. But like I said, you guys could always convert it to degrees and then convert it right back. Okay. All right. You guys could do the second one. You guys could just transfer this to the third one. Remember, I want 2 cycles. Fair? Yeah? Were you actually yesterday? Yeah. Okay. I'm recording. Let me shut it off.